For decades, Ghana has unsuccessfully fought the menace of illegal mining, and the devastating effects have been obvious for all to see. Polluted water bodies, more than half of Ghana's rivers filled with harmful metals, and many women experiencing defects on their babies. But to what extent have these heavy metals seeped into food items on the market? I took a trip to some communities infested with Galamsey in the eastern part of the country to find out. Over 280 forest reserves that Ghana has. About 43 of them have already been touched by the activities of illegal mining. Ghana Water Company Limited has repeatedly warned that it may not be able to treat, or sometimes actually has not been able to treat, sources of water needed to be treated to flow through our taps, because the turbidity level, NTU as they would normally shorten it and call it, has reached over 14,000, a minimum of 14,000 instead of about 2,000. That's far over what is accepted internationally. It all starts from here on this farm. Don't be deceived by the lush greenery you see right here, because just some few meters away you've got holes that have been dug here and illegal mining activities are going on. We want to take some food items to examine them to see or confirm whether or not the proximity of these farms to these Galamsey activities cause the chemicals to seep into the raw food items. So let's go. This should be about from here to where the illegal mining activities are. It should be about between 300 and 400 meters. From there, we move to other farms to pick the same samples of cassava, plantain, and even vegetables. I'm plucking some garden eggs and pepper from the plant that are just a few meters away from the illegal mining I've been talking to you about. We took these items to the ecological laboratory at the University of Ghana for examination and results. We want to understand what they did to the samples we brought to them and what the results are saying. I do have with me the principal technician here at the Eco Lab. They normally call it Prince Owusu.
Once sample is received, okay, we check the condition of the sample. If it's plant sample, we check whether it's dried sample or it's a wet sample. So if it's a wet sample, it has to go through drying in an oven at a temperature of about 70 degrees.
Celsius or Fahrenheit?
Celsius. So after drying, it has to go through grinding. So we have a grinding machine over there that has to grind it to a fine mist, like powdered something, before it goes through the analysis. So after that, we have to digest the sample. So here, decomposition has to take place. Okay.
What decomposition means?
Yes, so it means that samples are being referred to. All the organic material has to be converted into organic matter using an acid. And mostly we use the strong acid, the nitric acid, the perchloric acid, or the contaminator, the acid. Okay, so what happens is that once you add the acid to the sample, it converts. Let's say if you add the A2SO4 to the sample, it converts all the organic matter into carbon. Okay, so after that you put it on the block digester. Okay, you heat it, you give it a little heat, then you add what we call hydrogen peroxide. Hydrogen peroxide is an oxidizing agent, so it converts all the organic material into it converts all the organic matter into carbon dioxide. Okay, so the sample become colorless in this format.
Okay.
So it means that all the metals in the sample is now converted into solution.
So Mr. Prince Owusu just took us through really what is done to ensure that the results that come out are accurate. And I do have with me right now Professor Benedicta Fosu Mensah. She's the acting director for the Institute for Environment and Sanitation Studies, and this eco department is under her office, and of course she has a research assistant with her, Amwako Fori, and so she will start really giving us the result, and then Amwako will conclude with that. Ma'am, please tell us what you found from the samples.
The sampling is not a holistic sampling, that is not the entire eastern region, but they were just random sampling of some food stuff to really know the level of heavy metals in these samples, so as to know whenever you are eating, the amount of pollutants you might be consuming, and also your body by accumulating these heavy metals.
Okay, so I can see on your laptop that you have plantain like we brought, cassava, contomere, garden eggs, pepper. Just tell us what you have. I've seen some numbers here.
Okay, all right. So 5 heavy metals were analyzed in the laboratory, and then the food crops that were brought to the laboratory were plantain, cassava, contomere, garden eggs, pepper. So after our analysis and we found the various concentration, we also subjected it to permissible limits or guideline values. And so we chose WHO/FAO, which is the World Health Organization Food and Agriculture Organization limits, as well as EU limits.
The results are shocking. Food items have heavy metals far elevated above what is permitted, causing serious health implications, including brain damage and other related neuro diseases, nervous breakdown, among others, especially in children.
Manganese recorded higher values, and these values were in contomere, they were above 1, and their units for adults were 1.14 and 2.01 respectively. However, for children it was higher in contomere and garden eggs, and their values are 1.23 and 1.03 respectively. Then also we calculated for mercury, which is the target hazard quotient, and that one was also higher in cassava for both adults and a child, and they were 1.77 and 1.90 respectively. The next calculation or model we subjected it to is called health index, and then the health index is supposed to be the adding all multiple elements that you have analyzed together, and when you also sum them up, it shouldn't be above 1. But when we did a summation of copper, lead, zinc, manganese and mercury, all of them were higher than 1. They were in the range of 2 to 4, which means they were higher than 1, which caused some concern. So in summary, manganese and mercury had the highest concentration in all the food substances. So some of the symptoms of taking too much lead in your food sample, it could be exposure to even low levels of lead can cause damage over time, especially in children. The greatest risk is to brain development, where irreversible damage can occur. Higher levels can damage the kidney and nervous systems in both children and adults. Okay, so high levels of mercury exposure can lead to severe neurological damage, developmental problems in children, and even cause death in both children and adults.
All right, so you just got a bit of the details there from that research and the health implications of consuming these food items that are polluted with these metals. Of course, we're going to be having a conversation about this in studio and get a bit deeper into this very data that we've just received.